own condition data and also with any other data that makes sense for highways effectively. So we look at a lot of things that can build up a picture of how you would want to maintain your local highway. My background was as head of highways for Brighton and Hove City Council a few years back now. I've been with GAST for I think 6 years now. But prior to that, obviously, I worked in quite a flat organisation, so had quite a few teams working on all sorts of different things in highway maintenance, from winter services all the way through to street lighting. So that's principally my background. Since I've been with GAST, I've learned an awful lot more about how data works, which wasn't the case when I was younger. And so this session is to help others understand what we do and how we do it. Over to you, Olivia.
Thank you. I'm Olivia Sheward. I am one of the data analysts within professional services. My background is I did a geography degree specialising in GIS and mapping. And since then, I joined GAST, and I've been with GAST for 4 years now. And since joining GAST, I've focused more on my highways knowledge. I've worked with multiple local councils now, and I've done a few highways courses.
Brilliant, thank you. So that's really what GAST is about. It's about combining lots of expertise, experience and skills so that we can bring together everything that we need to help the highway sector. And this particular CPD session, obviously it has been approved by the IHE. It is very much about the basis for data really, and how that then works in the highway sector. So for some of you, you might find some of the, but if people already work with GIS, you might find some of the stuff a bit basic, in which case I apologise, but I certainly wanted to work from the position that I used to be in, which is, how does this really work? What goes on behind the scenes? So if you're all ready, I will start with a presentation on GIS. And then it will be followed up by Olivia talking about the application of that in schemes particularly. If anyone has any questions, please do put your hand up. Hopefully my colleague Kitty will let us know if we're focusing on what we're presenting, or you're very welcome as well to ask at the end of each presentation. Okay, the other thing I want to just check, sometimes because we do work with Google rather than Teams, it can be very temperamental for us. So if I'm talking and the slide hasn't moved on, please let me know, because Teams seems to do that to me. So I'm chatting away merrily thinking that you're all looking at the slide I'm talking about, and actually you're 3 slides back and nobody knows what I'm talking about. So please do tell me if that happens. Okay. Just to say as well, I did say it was CPD accredited. You will get certificates at the end of the course, which again will be sent out from GAST to your email addresses that you've registered with. Okay, so this first part of the session is going to focus on GIS in highways, and I'm going to go through a bit of background about GIS. So starting really from the very beginning, what is a geographical information system? Now, I think we're all pretty used to the word GIS, certainly, or the acronym if you prefer. And also we're much more used now to using mapping systems. Our phones tend to offer us ways of getting around and navigating. There's all sorts of ways that you can even maybe plot routes for yourself, cycle apps, etc., walking apps. So there's lots of ways that we now share mapping that wasn't available even 15, 20 years ago. And that's quite important to understand, that when things like highways networks were first created, these GIS systems weren't available to us. So over time, a lot of things have had to be digitized, and we're still, I think, with highways, making sure that we can transfer as much as possible into the digital world as accurately as possible. And that's not always as easy as it sounds. But what is a GIS a system? Effectively, it's a system that creates, manages, analyzes and maps data. And that mapping part is very important. So we talk about spatial data, by which we mean we're mapping it as it is in space, if you like. The things that you see on your phone, obviously, the maps that you can follow to find your way, there are limited ways that you can use that. So you can't necessarily create too much data, but you can certainly ask the map to provide you with hotels, etc. Obviously, what we need to do is get much more into the depths of how data works. And so we use GIS applications that allow you to do very much more with data, add in data, mix data, create it, etc. And for that, there tend to be some main applications, and some of the ones you might have heard of are QGIS, ArcGIS. That's often used by councils, I believe. We certainly did in Brighton previously, and MapInfo, which again can be used quite often across local authority. So these sort of applications allow us to visualize the spatial data as a digital map, but also to layer up multiple data sets so you can visualize more and more on one map effectively. And it also enables us to change how we view spatial data, as well as make edits to the data itself. So this is the part where we really get into making data work for us. So we can query it, we can analyze it, and we can do that in more detail and much faster than if we were using traditional paper maps or traditional paper records. Some of you will already have seen how GAST uses GIS. So here you can see at the background is aerial imagery. There's another layer here, which is OS Master Map, and that's the topographical representation of the UK. So that gives you elements of buildings, for example, green spaces, and you can see as well underneath the GAST polygons, you can see that it also maps carriageways and footway networks. It is the most accurate base map we've got in the UK. It's not perfect, but it's the best you can get, really, and it gives you an idea of road widths, for example, and footway widths. Now, a lot of people have their road network as a line. GAST opted to do a long time ago polygons, and the reason for that was because it spatially does represent your highway. So you're looking at your actual highway and all the kind of vagaries that has, all the little wiggles and spurs and things like that, but also because it then acts almost as the underlying system to look at your pavement, if you like, and to understand how it actually forms across the whole highway network. So I'm going to talk about the types of data used in GIS. Again, many of you will have heard of these, many of you will work with them. Principally vector and raster data. And I guess you'll have come across both in both your careers and in your private life, really. We're going to talk about vector data. It's the most commonly used, particularly for us and within highways. There are three types. There's point, line, and polygon. So again, you will have seen all of these in various formats. Point data, they have 0 dimensions. So, it's just literally a point. So no area or length, but they are actually represented by coordinates. So you've got the X and the Y coordinate. And with that, obviously, you can then place it on a map, and you make sure that those coordinates map the location. So you can use it for all sorts of things. Some examples in the highway sector, for example, you could plot the location of road accidents. You just want to put a point there. The location of building accesses, for example, so the entrance to a hospital or a school. Street lighting is a sort of asset that often gets plotted as a point data for obvious reasons. Other vector data, line data. So it's one dimension and you can use it to measure length. They have 2 or more vertices, so these dots here, and you can obviously join the line between these vertices. That does mean that you can start to become more sophisticated in how you represent things. So obviously you can start to put in some curves. Bear in mind, though, it's always a straight line between the dots. So you need more vertices if you're going to create a really nice smooth curve. And that's something to bear in mind when you're representing networks, particularly, for example, with lines or any sort of GIS vector data. And a typical example of a linear feature is a road network. So, or the original road networks, when they've been mapped for highways use, have been mapped as lines. So moving on to the final type, polygon data, it's 2-dimensional. So you can use it to measure area. And obviously it starts to be even more representative of the object that you're trying to map. So whether that's, in this case, we've got an example of building boundaries or lakes. And clearly what you're doing is you're joining the dots. So you're joining the series of vertices to make the shape that you require. It means that they're very flexible about representing things, although again, bear in mind that it is straight lines being joined to create that form. And an example of a polygon feature, they're often used for county or ward boundaries and for GIS condition data. So as I said, we've chosen to represent the highway network as it is, giving you width and length in ways that a linear network doesn't visually represent. So just a quick summary then. So you've got the points, the lines and the polygons. As I say, I know that possibly many of you on the call will already know this, but it was something that actually when I started, that it wasn't in my curriculum, so to speak. You know, we didn't have GIS online mapping. I know I'm showing my age there, but there are things that have to be learned, and it's been a very interesting experience for me to learn that. I remember the first time you know, we did get digital mapping in the council. It was quite exciting, and then we realised that we had hundreds of records that needed to be put on to a digital system, and that wasn't quite so exciting. Okay, so the other side of GIS data is raster data. And that's quite different. It's made up of a matrix of cells. So you can see here, each one of these is an individual cell. And within each of these, there's information and values. So that cell tells the overall map what to be, if you like. So it's built up of all these little pixels. And that tells you maybe coordinates, elevation, the colour that it should be. You'll have seen these time and time again. They're commonly used as background data for maps. So aerial, satellite data, digital elevation models, and scan maps as well. So if you scan something in digitally, it will be represented as raster data. If you're resizing it or enlarging it, you've probably noticed it can become quite grainy, so you lose some of that clarity. We use vector data because that's more appropriate for us, and we don't necessarily need to represent that sort of complete view of the countryside, if you like. But satellite and street imagery, it's really useful as the background, because of course one of the big things about highways is we're placing it within context. So that's not just about reactive repairs and third-party claims where you need to know the location, but it's also about, well, what else goes on around this road or this footway? You know, what is it that we need to do? What is it we need to consider? So highways obviously is not just within context, but actually helps, as we've often said, the whole economy and people and goods move. So I'm going to talk a little bit about coordinate systems, because this can sometimes seem like a dark art as well. So obviously, when we're placing things on a map, we need to know what coordinates to use. We now have a world geodetic system, WGS 84, much easier to say. So it's a global coordinate system. It was developed by the United States Defense Department. And obviously, if there's a huge amount of shipping, for example, moving across the world, or other things, navigation systems that rely on GPS, you do need a standardized coordinate system nowadays when there's so much moving around the world. So there was that need to basically standardize it. There were lots of different coordinate systems previously. So the way that WGS works is longitude and latitude. I know everyone will have heard of these and probably use them again. Longitude, it's the angle measured from the prime meridian and measured eastwards. And latitude is obviously measured up from the angle from the equator. So we take the Earth's centre as the point of origin and we measure from there, and we take obviously the Greenwich meridian. So slightly interesting. Why Greenwich? Why does it end up in a rather small country, the UK? And the reason for that is, fun fact, 72% of the world's commerce depended on the sea charts, which used Greenwich as the prime meridian. So that's a throwback really to the days when we really did have a lot of shipping. But also, again, even then, the world's commerce needed a unique point of reference that everyone could refer to. Okay, so that's, if you like, the world coordinate system. However, we had already developed one in the UK. So back in the 30s, we had the British National Grid, and that divides the whole of the UK into squares, and each one has a unique grid reference. And again, I think a lot of local authorities work with this, eastings and northings. So that will be a phrase that you're well used to hearing. And what they represent is, again, a distance from a reference point. So you take a reference point and you work the distances from there. Now, it's a planar coordinate system. So obviously, when we're looking at maps, even when we're looking at them on the screen, the majority obviously have to allow or work with the Earth's curvature. So when you're looking at British National Grid, the effects have been removed, which allows you to make precise measurements. So what we're talking about really is it's allowing you to place precise measurements on something flat that is representing something that's actually a globe. So it's not as easy as it sounds sometimes to work in referencing and coordinates, but there's some well-established systems now which really help us to place things where they need to be. A small shout out to What Three Words. Again, it's not a all singing, all dancing coordinate system as the British National Grid or the WGS, but it does allow some really good pinpointing of locations. And it just shows that things develop all the time. So as Olivia will talk about, we do use What Three Words in highways to identify for people, you know, the centre point of their schemes, for example, or things like that. So it can be a very quick and easy way of identifying where you need to be, but it has limitations because it is only that square, and it doesn't give you beginning and end of things unless obviously you write out loads and loads of squares. So at GAST, we use British National Grid, BNG, for consistency. And I've shown here, if you use data sets with different coordinates and you just import them straight into your system, you'll find that things are off because the coordinate systems don't match exactly. They're not compatible. So I've shown here streetlights, for example, which are not in the right place because they're ever so slightly off when they project into the British National Grid if they were first, their coordinates were first set up in WGS. So that's something to bear in mind when you're working with it and to check what coordinates you're using compared to the system that you're putting them in. So some of what we can do is reproject into a GIS system. So we'll change the coordinates to make sure that the spatial queries or the matching is accurate. We do provide a data viewer for people to see our data and other data. It is very much, it's not an all singing, all dancing GIS system. It's about enabling people to look quickly and easily at their data, rather like you might use Google Maps or Apple Maps or things like that. You can turn data sets on and off, so you can have a look at different things. So you can have a look at condition data versus schemes, or all your different assets next to each other, or just a single data set at a time. And you can filter as well. And the data can be exported. So that makes it very easy to go into your own systems. Now, we talked about coordinate systems and making sure that it's projected at the right coordinate system. So with Asset Stream, if you're exporting anything, you get the choice of what coordinate system you want to export that information out as. And what you'll want to export it out as is whatever fits with the system that you, as the council or an individual, are using. And then it can go straight into your asset management system and things will be put in the right place on the map. Just a little bit about file formats. Again, shapefile, very common. Most people still use shapefiles. They do have some issues. They can shorten file names, for example, or also the names of the record. So, you know, there's some drawbacks to shapefiles, but they're very quick and easy to use. And they store geometry, the points, the lines, the polygons, and any other information that you've got in there. So literally you can just drop the shapefile, the SHP file into any GIS software, and you can view that data spatially. The same with the tab file. So that's a map info file, and it works really much the same as shapefiles. So you've got the multiple files all together. And those multiple files allow the spatial data, and literally you drop the tab file into GIS software, and again that will pull the data into your software system. You can also use spreadsheets and CSV, but they must contain geometry. So you can open CSV files with spatial referencing. but it needs to be there. So you can see here, we've just put an example of geometry definition. You can see X and Y fields, or it could be in a well-known text field. But you've got to say what you're using. So you've got to say here, well, British National Grid, and it's got to have some sort of coordinates in there for it to actually work and to make sure that the file can be projected to the right location. You can have a spreadsheet or CSV with no geometry, so it can contain all the other information, and you can export what is on a map as a spreadsheet with no geometry. You would just end up with things like the attributes, so road name, ward, etc., etc. So you can look at all that information, but it's not plotted to a location, and you couldn't plot it to a location because there's no coordinates to tell it where to sit on the map, your base mapping system. Okay, so those are the ways that you can set up data, use data. I'm going to talk a little bit more about using it as we go through the session. One of the things that's really important in data sets is a primary key, so a unique identifier. It means that no record can be duplicated and you can distinguish between things. So if you've got two people with the same name, surname and first name, you can use a primary key to make sure that you can make the differentiate between those two records. Here we put an example as a national insurance number. In highways, obviously, we use things like USRN or ESUs to identify sections or roads so that we can tell the difference, because obviously you could have more roads with the same name within your county boundaries, within your local boundaries even. Certainly within Brighton and Hove, there are 3 Coronation Streets, for example, at least a couple of Princes Streets. So in itself, a name is not sufficient to make sure that you've got the correct location. Even if you add ward in, it becomes a cumbersome way to find out where you need to be. So most, if not all, data sets should have that primary key, and that's also a way of joining things together as well, that you can take that primary key and use it. Okay, so how does it help? Well, coordinates, really, they're the very basis of spatial data, and we need them because they make tasks much easier, much more efficient, much quicker. So I mentioned before, if you're having road names and you've got a spreadsheet but no geometry, yes, you can look at working around it and trying to find which roads have the same name and where they belong, but it is time consuming and it can lead to inaccuracies. So hence the coordinates really and the primary key take us exactly to where we need to be and cut out a lot of more manual work in trying to plot things to where they should be. So I put in some challenges to working with GIS. I'm going to talk about use cases after, but we've talked about projections. So you need to change the projections, the coordinates, to display correctly alongside other data sets. We've done work abroad with international data sets, so that's always an interesting challenge to make sure that, for example, their linear information or their topographical information works with coordinate systems that we're using with GPS. So you can see there's lots of different ways that coordinates can come into, first of all, capturing the data, and secondly, displaying it, and then thirdly, using it. Data sets can have quality issues, so there can be corruptions or there can be errors in it. So we have to fix those geometry issues and tidy the data sets before they can be used. And some of that can be quite simple and straightforward. Others can be more of a task depending on the types of errors or the types of issues that have arisen. The applications can be temperamental. They can have issues with loading large data sets. Like anything else, that's an awful lot of information for the computer to deal with. And sometimes the application can give up and you have to start again. The other thing is that, I think I said earlier, there's no quick or easy way to digitize data sets from non-spatial spreadsheets, maps, images or records. It can be done. I'm sure a lot of you have done it with some of your older information, and we've done it as well on behalf of local authorities, but ultimately it's a very manual piece of work. So even if you've got an image, for example, or a drawing, if that's just a standalone drawing, it still has to be plotted into GIS. So somebody has to take that and actually make the polygons or the lines on the right map, with the right projections, with the right outline for what you're trying to display. So a good example of work that we've done is adopted highways, so records way back from the time that they were written into books and actually drawn and annotated into books or files or folders. And we've done a lot of work that was PDF to us, and we did some work making sure that was all digitized. Of course, once it's done, you've got that information then to use again in a very quick and easy way. So it's definitely something worth doing, but it is very time consuming, and it does require an element of good knowledge about how to work with GIS and, you know, how to work with all the various ways of doing things. So behind the scenes, we've got experts that can write quite a lot of code that will simplify things. Even some of the manual work can be hurried along by writing GIS code. But obviously, there are still ways where it just has to be manual, or you have to identify anomalies within that might make the code not run until you fix that anomaly. And the final thing I want to add is there's no such thing as perfection. It would be fantastic if there was. Even OS highways is not perfect. If we're looking at linear data, for example, you can have a very busy junction where you've got lots and lots of lines crossing over each other. So that line shows that that's the A road there, but then there's this here, and then there's a road bridge over, and that can be very, very hard to then plot accurately on a map, particularly again if you're showing polygons rather than lines. You've got to work out which intersection goes where. And then of course with highways you do get strange things where the main road actually goes off at a bend and it looks like the actual main road is there, and that's actually the B road, but it's not well defined either by geometry or by road class and your base mapping. Or you get little spurs, and things like footways can obviously have bits where you've got all sorts of crossovers and things like that interrupt the flow. So all of this, when it's being, you know, put into a GIS system, they're absolutely brilliant. They make a huge difference to how we visualize and work with data, but it's unlikely that you're going to have an absolutely perfect representation of your world. We get as close as we can and do a lot of work to make sure that it is. Okay, so I've sung its praises. I'm a convert to GIS data, etc. How do we use it? How does it help us? Well, one of the ways is obviously understanding patterns. Like if you're viewing something in a table or in a long row of spreadsheets, it can be sometimes hard to pick out those patterns. Whereas if you can see things in data, so often it doesn't take long for us to realise where there might be a lot of parking on the footway, because we can see this pattern of, like, you know, grade 5 all the way along at various locations, and you're pretty sure on a footway that'll be because it's taking weight that it shouldn't, for example. It can help us identify relationships between things. So lots of different data sets, when you view them visually, they start to make a lot more sense than if you're trying to sort of match things on a spreadsheet maybe. So a good example there, accessing a road to a hospital. So if you can see the illustration that I've done, here's the hospital, and this is a flood risk area. So this is something that has been plotted separately, as, you know, what's the chances of flood water. And you can start to assess risk then. So is it likely to affect the hospital? You know, do we have to mitigate risk, or actually is that okay? You know, is that flood risk far enough away? What are the access roads to the hospital? Will the flood risk affect those? Should there be that, you know, a one in whatever event? So these are the types of relationships that we can start to see, and then we can start to actually make them meaningful and actually draw analysis and conclusions from that. And that helps direct what we're going to do and how we're going to do it. So how else does it help? Well, spatial queries. So that's something we can remove duplicate geometries. So often with asset inventories, they can be built up over years, and sometimes people forget to remove the old asset when they're putting something new in. Certainly, you know, I've had that before, where you've got a concrete and a steel column in the same location. It's probably one or the other. So again, we can visually see very easily, and we can run particular code that will pick out where there are duplicate geometries and say, well, actually, this is what it should be. So it gives us that opportunity again to I say very easily, there's still work to be done, but to tidy things up and to make things more accurate. And this type of thing gives us the ability to create maps. You know, a lot of councils I know don't necessarily have easy access to all sorts of GIS applications or the full range. So that's something that we can do quickly and easily. So last couple of slides from me, and then we'll move on, any questions and over to Olivia. But how do we use GIS? So within GAST, and certainly for our customers, condition data. So I've said earlier, we choose to use polygons because it's much more of a real world replication. Each polygon has a condition grade, and it also has a detailed record. So that gives you all the information that you need on what's going on at that location. So the damage types, the referencing, so USRN, the road name classification. We give surface type, and you're getting damage area measurements and length and width. So you're getting an awful lot of information that will tell you what you need to know about that particular location. Asset data, obviously I've talked about things like street lighting. You can have all sorts of asset data mapped, and I'm sure all of you do in one way or another, and also periodically update. So particularly things like signs, not always updated as and when they go in, or condition of things like road markings, for example, that can change over time. So asset collection can be about not just location, but also the type, the condition, DFT diagram numbers, for example, all again, that information that you need to know if you're going to be doing a good management of those assets. We upload it to Asset Stream, but it's because it's a GIS system, it can be loaded into other systems. And again, with the right coordinates, it should match perfectly into your system with your other data. And that's something very important. So when highway networks were first created, as I said, there wasn't the same access to GIS. And so pavement management systems were based on the best network that could be drawn up at the time. But obviously times have moved on, and geographical information systems now provide the opportunity to be very interchangeable with data. And so GAST again chose right in the beginning to work along GIS lines rather than maybe to fit into just the old pavement management. So it makes it much more fluid, it makes it much more easier to compare to other data sets, it makes it much more easy to bring in data and analyse that data alongside. One of the things we do at GAST is client networks. So we consolidate all the information. So often information about the highway network can be contained differently and in different places. So OS Highways gives you a good topographical representation. This is what it looks like, and it can be quite good on area, but it's not always very good on road class, for example. So it's usually pretty good on AB, but not necessarily on C roads. Not very good on maintained. Some of that does sit in the street. Well, most of it, all of it sits in the street gazetteer, but it doesn't necessarily get reflected in some of the ordnance survey data as accurately as we might like. So a lot of what we do when we start off with a new customer is we collect all that data and we make the network reflect all of that in one place so that you've got everything you might need about your network in there. Again, a word of warning, a lot of bespoke referencing can be very time consuming, and there may have to be some manual processes that match everything up. So there are some really easy information to get, such as adopted roads from yourselves and road class, A's and B's from OS Highways, but there is some more bespoke referencing, which can be more time consuming. But things like UK PMS referencing, coordinates from USRN, ESUs, those things are pretty standard and very easy to add into the network. So you can have all the referencing information up front that will fit with your systems. And that all goes in with the condition data. Okay, so that's it from me. Olivia's going to take through information about how we use schemes, how we use GIS, for schemes for both identifying locations for maintenance and for how to prioritise those. So I'm going to come back to Teams there. Does anyone have any questions before we go on? No? Okay. Okay, over to you then, Olivia. Oh, you're on mute, Olivia. Sorry. You're muted.
Sorry. I wondered why no one said when I said, can you see my screen? I'll be taking you through the scheme identification part of this morning. So to kick us off, what is scheme identification? Well, it's the process of turning condition data into meaningful schemes. And this means aggregating individual locations into a logical area or length for maintenance. Schemes can differ depending on what type of maintenance is being carried out. So, for example, poor condition might need a resurfacing scheme, whereas an average condition might just need preventative treatment. Um, and scheme identification is an essential part of managing the highway asset. Scheme identification fits within the asset management framework. And asset management is a set of activities that are designed to get the best out of your assets. So for local councils who have the responsibility to maintain carriageways and footways, the carriageway and footways are the assets that are being managed. And the idea is to maximise the value of those assets to society as a whole, and the local and national economy, and to do it in a way that is most cost effective. And so this usually involves planned maintenance and capital budgets. Planned maintenance works that are not immediately urgent. It's not necessarily about fixing potholes. And when we spend money that is intended to generate ongoing benefits, that expenditure is referred to as capital. So within planned maintenance, there are 3 types of maintenance that we typically refer to, or that our clients are primarily interested in. Structural maintenance, which includes resurfacing, is designed to restore the structural strength of the road, and that could be achieved by simply replacing the top 40 millimeters. So it's not necessarily about reconstructing deeper layers, although it does obviously include that as well. Preventative maintenance, which includes surface treatments like asphalt preservation, surface dressing, micro asphalt, and others, are primarily intended to keep the surface sealed to protect it from the elements, slow down the aging process, and prevent water damage from getting into the structure of the highway, where it can cause damage and breakup of material. And what those have in common are they are a lot cheaper than structural treatments. So they could typically range from sort of £3 to £12 per square meters, compared to £25 to £150 per square meters for structural. And then on the reactive maintenance side, we have pothole repairs and other remedial, sometimes urgent responses. The important point with this is that before a reactive repair happens, there actually has to be a failure of service. This isn't necessarily the case of planned maintenance. So in a sense, one of the objectives of planned maintenance is to reduce the need for reactive maintenance. Planned maintenance helps to deliver a more reliable service, fewer unexpected failures that cost money, and so it's a balance. You can't eliminate potholes altogether, so we have to find a happy medium point. We also have localized patching, which is sort of in the middle ground, where we don't do all-out resurfacing, but instead make repairs that are intended to be more durable. They usually require larger repairs extending beyond the immediate pothole or safety defect, and these can reside in either the planned maintenance or the reactive maintenance camp, depending on the urgency of the repair and whether or not the council has the mechanisms and resources to carry out these types of repair within a short time frame. And sometimes it can also just be a case of which budget it should come from. Structural maintenance is very costly, nearly always the most expensive treatment. It requires a lot of new material, and unfortunately, there's still a lot of disposal of old material. It's often carried out where there are simply no other alternatives to address the problems there. So in that sense, we could argue that a lot of structural maintenance is also reactive, albeit it takes a lot longer to plan and deliver, but the end result is nonetheless a substantial improvement in the value of the highway asset. So what do we do with all that information? Well, we have scheme identification, which is designed to help identify specific areas suitable for a range of treatment types, several which we have already touched on, but scheme identification is looking at a 1 to 3 year timeline and is based on the current condition. The scheme identification should be data-led, which means that the highway officers can provide evidence for why they have made their decisions about what to include, and data can assist with identifying candidate areas for maintenance, i.e. a long list, and also providing information against which to score and prioritize your long list. There are different ways that scheme identification can be carried out, but the process does require up-to-date condition data as a minimum. In terms of using this data, software tools are usually used to produce a scheme list. So it could be an Excel spreadsheet, but it could also be a built-in option on a software system. GIS scheme toolkit works using spatial data. So the schemes are mapped in a highly visual way, and the tool is governed by a set of criteria which represent a client's engineering treatment rules for different high-level maintenance options. And these are the inputs into the software that requires some human-led discussion as well. Once the criteria and the parameters are defined, the software tool is run to generate an output that defines the suitable locations for different treatment types. Here we have an example of what this could look like for the carriageway. So on the left, you have our condition data with a key that breaks down our 1 to 5 grading system. So these blue areas are grade 1, which indicates they're damage-free. So where you can see the larger areas of blue, this indicates that some treatment has likely taken place prior to the survey. Then at the other end, we have a grade 5, which represents structural and/or severe surface impairment. Looking at the right, we have some example schemes. So we've got resurfacing, patching, and surface treatment. This shows how we might aggregate the individual locations into a logical area for a scheme. Within the outlines of the scheme extents, you can see that the resurfacing scheme is mostly grade 5. This is typical of a resurfacing scheme, but it's also common to have quite a bit of grade 4 in there as well, as those areas would be functionally impaired. You can see that there is also some grade 3 included in the scheme. This is because to create the illogical scheme, we allow small amounts that aren't the target grades. Patching is usually looking at much smaller extents than resurfacing. So here you can see that there are some smaller patching schemes which are focused just on grade 5 areas. And because of this, we don't usually allow additional grades there. However, with surface treatment, looking at mostly the grade 3 or serviceable areas, we've got much larger schemes, and you can see that it is mostly grade 3, but does include a few areas of grade 2 and 4, which have been allowed to create that logical scheme. With the footway, it is a similar idea. We can see here on the left an area of grade 4 separated by some grade 3, and this has been aggregated into one scheme. The image at the top shows the imagery behind the data, and in this location we can see that there are a lot of broken flags. The imagery is a really useful tool that can be used to view the location of any schemes and can help to visualize the damages that are causing the area to be a certain grade. So here we have some more example schemes. So figure 1 shows a surface treatment scheme that has been identified using the road class as the search boundary. And this allows the scheme to cover multiple roads within the same road class. Figure 2, on the other hand, shows resurfacing schemes that have been identified using road name as the search boundary. And this means the scheme can't extend beyond the end of the road. Search boundary is just one of multiple criteria that need to be specified to create a set of parameters for each scheme type. So some of the other criteria are what we call the trigger, which is the starting point for identifying schemes. In the example here, the trigger for surface treatment is grades 3, 4, or 5 with a damaged area greater than 10%, and for resurfacing, grades 4 or 5 with a damaged area greater than 10%. The scheme profile helps define the scheme in even more detail by specifying minimum amounts of certain grades and can include specific damage types. So in the example shown in figure 2, the scheme should have a minimum of 60% grade 4 or 5 or 60% grade 4 or 5 with damages like rutting or wheel track. There's also a scheme avoid, which allows us to restrict certain grades, such as maximum 5% grade 1 and 2, as was used for the surface treatment scheme in figure 1. Scheme rules dictate where a scheme can be identified, for example, not on a roundabout or a major junction. We also have a minimum scheme size. In the examples here, both surface treatment and resurfacing were a minimum of 500 square meters. This ensures that the client doesn't get any schemes that are smaller than what would be cost effective to carry out. The other two criteria are the gap and snap criteria, which are often the most confusing for clients. However, you can see in figure 2 how the snap criteria has extended the left-hand scheme to the end of the road. So there are 2 grade 3 polygons at the end of the road, which don't meet the grade 4-5 trigger, but because the end of the road is within 50 meters, the scheme will extend to include that. Figure 2 also demonstrates the gap criteria, so we can see here that there are grade 3 sections within the scheme as well, and this is because the client chooses a gap tolerance based on how comfortable they are including other grades within a scheme. So you usually don't want gaps of grade 1, 2, or in this case 3 as well, that are too large, as there are tight budgets, but using a maximum of 50%, as they have done here, allows a logical continuous scheme to be created. So simply put, the gap criteria is looking to join areas within a specified distance, such as 50 meters, that meet the trigger and the profile criteria, but maybe not the minimum scheme size. So then when they are combined, they do meet the minimum scheme size. But to combine, some locations of additional grading are included to bridge that gap. Whereas the SNAP criteria looks to join schemes together and extend to the end of the road section within a specified distance. This provides an overview of the whole process from start to finish. So on the left-hand side is the start of the process, where we sit down with clients and shows how the first draft is completed once we receive the questionnaires and condition data. And we can spend a while going through feedback and changes, as it is an iterative process, but eventually we finalize the process and apply the rankings and inform the account manager. The process doesn't always look like this every single time. Repeat clients usually don't fill out a new form each year, but will review the parameters used previously. As schemes are based on current condition, in theory, all of those locations could benefit from some form of maintenance. Depending on the condition of the network, clients could find that there are a lot of locations that need treatment. So whilst a long list of schemes is a starting point, how do you decide what takes priority for the available maintenance funding? Well, we achieve this by looking at what's important to the local authority alongside highway requirements such as safety and sustainability. So important priorities could be to support economic growth, reduce social exclusion, or encourage active travel. And we use scheme prioritization to do this. So scheme prioritization, or ranking as we often call it, is used to help clients pull out schemes that are the most important according to their priorities. To do this, we use a range of data, and this form shows some of our suggested ranking criteria that clients often use. The scoring system and the data sets can be customized to the client's requirements. For example, clients can provide their own hierarchy rather than using the ABCU classification. You could also provide your own accident data rather than using historic data from the DFT. And any additional criteria that a client might want can be added in, providing the data is available in a spatial format. And this could include highway data such as reactive repairs, and past clients have also included things such as bus routes, for example. I've already shown several examples of what the schemes look like, and I know Christina showed something similar to this as well. But this is how the schemes would look on Asset Stream, which is our data viewer. So the panel on the left shows all the layers, and these can be clicked on and off, which would allow you to view the condition data at the same time as the schemes, and also flip between the two. Each scheme can be clicked on individually, and the information will appear on the right, showing important details such as the area, surface types, and score. And a link to the imagery can also be accessed from here. So in terms of designing the schemes, site visits by highway staff are usually required to visually assess what's been identified and start the process of designing the scheme work. GIS provide full roadscape imagery with the condition data, and this means that much of the initial checking and design work can be carried out at your desktop, involving as many people as necessary and saving time-consuming site visits. So the image here shows a snapshot of our high-resolution imagery, and you can see that you can view the damages and the defects in very high detail. In terms of the deliverables that you get from scheme identification with GIS, the outputs are provided in several formats. So we provide a shapefile or another GIS format if that suits more. We provide a CSV, the map-based representation through Asset Stream, as well as a scheme delivery report. And we also add the what3words center point ID of each scheme. This is particularly useful if you are viewing schemes using a CSV. And this screenshot here shows how those schemes might look in a CSV format. So you've got all the same important information that's held behind the visual data in the spreadsheet, including the grade breakdown of each scheme, and past that grade 5 column, there's not quite enough room here, you would have a column for each of the ranking criteria and then the score as well. So what are the benefits? The engineers or inspectors have more time to review schemes and make final decisions. Schemes primarily focus on the 1 to 5 grading system in the condition data, but we can also specify percentages of damages that a scheme should meet. For example, resurfacing should be grade 4 or 5 with a damaged area greater than 50%. And we can also specify specific damages in the profile criteria. An example of this would be 40% of the scheme should be made up of grade 4 and 5 polygons where the damages are rutting or wheel track. The scheme selection and prioritization is not biased. The client is free to manage the network in an objective way rather than have any pressure, such as from councillors. Clients will also have more schemes than they can afford to do usually. And this is still helpful though, as they can be aware of new locations that might need monitoring or look to build a multi-year program. Also, sometimes clients with larger networks can't always monitor all of the roads regularly, and clients with smaller networks can't always keep up to date regularly. And lastly, one thing that helps clients when they have lots of schemes is the prioritization. And we can work with clients to match the current maintenance priorities, as well as introduce other data sets that allow the schemes to be prioritized. And this helps clients decide which schemes should be done first based on socioeconomic factors. Some of the positive feedback from clients have said that the top schemes that we've given match locations that they were already monitoring, which is great because if it aligns with what you're already aware of, it means that you can trust schemes and locations that you weren't previously aware of. This means that there is a high alignment between the list that we provide and the list that the client carries out. Thank you. I'll stop sharing and come back.
Thank you very much, Olivia. So hopefully most people have stayed with us through that. Has anyone got any questions, either about GAST or about some of the stuff that we've talked about? Anything anyone would like to know? It's silent. I'm hoping the silence doesn't mean you've all been doing emails instead. Although it is quite hard when it's online not to be distracted by other things, I know that. No? Okay. All right, well, if there aren't any questions, oh, hang on, someone's got a hand up. Richard, yes.
Hi there.
Hello.
Yes. Sorry, I was a bit late to stick my hand up there. It was just a quick one on the referencing that you use. So the way we do things here in Hertfordshire is that we've got a deterioration model, and the way we currently use condition data is that we bring it in and then we use it for our strategic planning as well as our forward works programming. So when how easy is it to reference our network system? I think you mentioned that UK PMS it can pick up. So is that a straightforward exercise to do? And how does it work?
Yeah, so the UK PMS referencing, we can literally just put in as accurately as possible against the network we produced for you. The only issue might be that so with UK PMS, obviously in a line network, often where you start the road could be at the centre point rather than at the exact junction, whereas where we start is the bell mouth of the junction, if you like. So what you might find is that your naught is slightly earlier than our beginning for that road. Does that make sense?
Yeah. So is there an element of getting the section lengths to fit then? We don't
necessarily, because that would distort the GIS, so to speak, because for people who have worked with UK PMS, you often have to fit the network, don't you, basically? So you fit the data into the network that you've got as the base. So I mean, UK PMS, it was the best that we had at the time, and it was brilliant. It gave everybody the opportunity to match data to a network. But it probably has become more dated as GIS systems have evolved. So the original count, obviously, so that the starting for the chainage, you have to choose a point, don't you? And for a line network, that was often either the middle of the road or some point. But where we start, because we're using topographical, we can start it exactly at the junction. So that's the difference, really. So all the chainage will be in the right place. The chainage will be exactly as it is in your UK PMS system.
Right, I see.
Does that make sense?
Yeah, so it's I think so. I mean, I'm not an expert in this, but I think the way the scanner works at the moment is it's got a measure on the vehicle, and that's why we end up with these differences depending on exactly where they start it and finish it. So okay, but because you're doing it on GIS, it should match. Because the UK PMS has been based on the GIS or the mapping, so they should match. I see.
Yes.
Right. Okay.
Yeah. And we can put the chainage in alongside any other referencing. That's very straightforward. Those types of referencing, USRN, ESU, UK PMS chainage, that sort of thing, that's very straightforward to add. It's better if we add it right at the beginning, though. It's just a bit more work to add it when we've produced all the data. So, if anybody is, using our data, then just give us that information right up front. Yeah.
Okay. Yeah. Thank you very much. I do have to leave, but thank you very much. I found that really useful. It was, because I'm not an expert in this, but that session was really useful. So thank you very much.
Yeah. Thanks a lot, Richard. Yeah, and I wasn't an expert, which is why I wanted to do it. So appreciate that.
Brilliant. All right. Okay. Thank you. Bye.
Cheers.
Bye.
So if there's anyone else want to ask anything? Neil, I think you are an expert.
So
You're welcome.
I'm Neil Waring. I do the GIS highways work and data for Lancashire County Council. Our network, as you know, Christina, is huge, and currently we survey 6 of our 12 districts each year for our unclassified programme. So it's over a 2-year rolling programme. So this year we've had a particular issue with our surface dressing programmes, and quite a high percentage of the schemes we put forward based off data-driven analysis have been coming back from the engineers saying when they visited site they've further deteriorated. The predominance of those are from the older surveys, 6 months. So I was just wondering if there is a way when the schemes are created to capture the date that that survey was done on within the scheme. So if it's created from those condition polygons are dated to the previous year's survey now, exactly in our case.
Yeah.
If we could capture that date and we provided an up-to-date cut of, say, pothole data, would it be able to get a count of the number of defects reported after the survey was done? So we could get an indicator of any deterioration for those particular roads that's occurred since, because sometimes we've been looking at schemes that were obviously because of that 2-year run that we have, some of those schemes are generated from data that was in September, October of 2022. So now they've had almost 2 years worth of potholing in addition to when that was done. So if there was a way to incorporate that post survey date when we're doing our 2-year cycle, I think that would be a really good indicator for us to be able to see where those surface dressings as they were are perhaps now rapidly failing, or they have had a lot of deterioration in the last couple of years and may now contain too much patching to be viable.
Yes, understood. I'm not sure about the date. I certainly know with the reactive repairs, I'm going to let Olivia answer that one because she is much more of an expert on the schemes than me, actually.
Yes, so we could take the schemes and take the pothole data if it's mapped as individual points, and we could basically just intersect those 2 data sets. So we could add a column and use a count of how many potholes intersect with the extent of each scheme, and with the date, I assume we could just add a column for the survey date that the schemes are based off of, and a column for when that pothole layer had been collected.
Yeah, so all the potholes have point data, and they all have the date that the jobs was ordered on. So if the job date falls after the after the survey date for that condition, then it'd be really useful to have a count of post survey date potholes.
We could definitely do that. Yeah, definitely.
Yeah.
Brilliant. Thank you.
Cheers. And then there's our very own Steve Birdsall, I believe. Is that right?
Oh, sorry, I can't seem to get my hand to stop being raised. I don't have any further questions.
I don't know how to either. Oh, it's gone. Yeah. Steve. You there?
Sorry, yeah, I'm here, Christina. No, I didn't ask a question. I beg your pardon.
Oh, your hand just raised. Okay, that's fine then.
Yeah, sorry.
Okay, no problem. Anyone else? Okay,
so about sharing.
Okay, thank you. Well spotted. Oh yes, we will. We've recorded it as well, so we can share that with people if you do want to listen to the recording again, and we will share the presentation. So we'll send that out along with the CPD certificate at the end. So no problem. So I wanted to add, there's lots of things that you can do with data. There are some limitations. If you do want to know, just ask. And again, one of the things that I said about GAST is that, you know, we combine a lot of different knowledge, and we're not afraid to defer to the people who know better. So actually, that's a really good way of making sure that we bring the best to our customers, really. So if I know slightly less about GIS, I've got Olivia to rely on, and vice versa with the highways stuff. So that's something that, you know, we really enjoy combining. The other thing I want to say is, you know, I really appreciate you guys coming on and listening, everyone. as I say, I had to learn these things myself. So I very much wanted, you know, when we're presenting these things and talking through, it could be very basic for some people, and obviously you know it already, but I think for others hopefully it's quite helpful to sort of think about, oh yes, we talk about these things every day, but this is how they actually work. So please do come back to us if you think of any questions or you've got any comments after. Obviously we'd be very willing to talk to any of you some more about GAST itself and what we do, and with existing people who use us, like Neil had a question there. There's lots of things we can do to make the whole process better if we know what you need. So much appreciated everyone for coming along, listening to us, and yeah, please get in touch and we'll send you the information afterwards. Okay, thank you very much everyone.
Thank you.